Okay, so I feel like I'm being live. This is a live recording. I'm just setting up new things. So this is the OBS studio, and I'm connected with a laptop, Razer Blade. So I'm just gonna go through these exercises. Hopefully, we can get these finished.
Okay, so in this lab, we're going to look at rolling updates and rollbacks. So rolling updates mainly. So going forward, I'm going to try and use the alias K for kubectl. So I've already set an alias K for kubectl, so I'm going to try and use that going forward. So we have deployed a simple web application, inspect the pods and services. So let's do get pod. So there seems to be a front end, a set of front end pods. Most likely there is a deployment. So there's a front end deployment which deploys 4 pods. Then wait for the application to fully deploy and view the application using the link called web portal. So there's a link here. You can click to view the application, and it opens it up in a new window. It just says hello front end. Moment. Okay, so let's look at the first second question. So what is the current color of the web application? So if you look here, it is blue in color. So it's blue. Now run the script named call test to send multiple requests to the web application. So we have roll test here, so I'm going to run that. As you can see, all it does is it pings the application and returns a color. So the color is blue, and it just keeps running that for a few seconds. So that's done. So we're going to use this script to run tests on to kind of simulate accessing the web application by either like multiple users, so or sending multiple requests to the web application.
So it's kind of like similar to how we did before. Just need some light here. I'm gonna connect. Hopefully that's
So
better.
we'll use that to basically just do a small round of tests on the application. And inspect the deployment and identify the number of pods deployed by it. So we just looked at that and we saw that it creates 4 pods, so it's 4. That's the answer here. Now, what container image is used to deploy the application? So let's look at the deployment in more detail. And content. And here we have the pod template. We have containers, image. The image is called cloud/web app color v1. So it's this one right here. That's the image we've used to deploy the application. Now inspect the deployment and identify the current strategy. Content. And we just looked at that and we saw that it creates 4 pods.
Identify the number of pods deployed in it.
So it's 4. That's the answer here. Now what container image is used to deploy the application? So let's look at
short. He did a K as an alias. You can set as an aliases and then just say K describe
the deployment
and what container image is used to deploy the applications. And then you can just say
in more detail.
Deployment.
And
we say front end.
Content. And here we have the pod template. We have containers, image. The image is called cloud.
Containers, and then we have image code cloud web app color v1. So that one over here.
Web app color v1. So it's this one right here. That's the image we've used to deploy the application. Now inspect the deployment and identify the current strategy. So if you look at this,
if you inspect the deployment, and you can see over here rolling update strategy. I see over here. Okay. Rolling update strategy. We told about 2 different strategies: rolling update and recreate. There are 2 types of deployment strategies. Now, by default, it's rolling update, but recreate is like a problem because application experiences downtime. Now, what it does is that it destroys all at once, and then what rolling update is like, it take down the older version and bring up a new version one by one, and a newer version is deployed by first destroying all the existing versions and then creating newer version of the application. So that's basically recreate, destroy all at once. A newer version is deployed by first destroying all of the existing versions and then creating newer version of the application. Yeah, and it experiences application instances and it does experience downtime. So it says over here rolling update. It's
we have the strategy type given here, and that is rolling update. So that's
okay. It said over there too, and it says over here too. Interesting.
This the rolling update is the current strategy. Now, if you were to deploy, or if you were to upgrade the application now, what would happen? So we know that the rolling update.
I'm assuming my audio is working. Just let me check. Streamed audio is working. Man, I should change my thumbnail.
There's so many Black Friday deals, cyber reviews, things I just want. Very little do I think updating.
Streamed audio is working. Man, I should change my thumbnail. Yeah, I think it's working.
takes down, what would happen? So we know if you were to deploy, or if you were to upgrade the application now, what would happen? So we know that.
You know what? I would change my thumbnail too. Let's see, so like the settings here. I would just like delete it. I can't change it. It would ask me for another one, and I don't have any thumbnails. You know, what I can do is I can just find something random on the internet. Coding, stream, right? Thumbnail. Images. I don't know, I just like this one. Save image as binary code. Binary code. Save. Alright. Throw your messages in the chats if you have any.
The rolling update takes down one pod at a time and brings up the new pod. So it does not wait, it does not take all of it down one pod. So we know that the rolling update takes down one pod at a time and brings up the new pod. So it does not wait, it does not take all of it down and bring the new ones up. So answer here is all pods are taken down before upgrading. No, that's not the correct one.
So if you were to upgrade the application now, what would happen? In rolling update, pods are upgraded few at a time.
Pods are upgraded a few at a time. So that's the correct one. Now let us try that. Upgrade the application by setting the image on deployment to Code Cloud Web App Color v2.
So it's saying let us try that upgrade. Upgrade the application by setting the image on the deployment to Code Cloud Web App Color v2. Do not delete or recreate. The deployment only set the new image for the existing deployment. One second. All right. Alright, let us try that. Upgrade the application by setting the image on the deployment to this one. Do not delete or recreate the deployment. Only set the new image name for the existing deployment.
So we're going to code. Let us try that. Upgrade the application by setting the image on. Let us try that. Upgrade the application by correct one. Pods are upgraded a few at a time. So that's the correct one. Let us try that. Upgrade the application by setting the image on deployment to Code Cloud Web App Color v2. So we're going to update the image. Now one way to do that is you could do a capital edit and deployment and front end, and then go here and change. And deployment is you could do a.
So yeah, let us try that. Upgrade the application by setting the image on the deployment to Code Cloud Web App Color v2. So do not delete and recreate the deployment. Only set the new image name for the existing deployment. Okay, I got it.
The image on deployment to Code Cloud Web App Color v2. So we're going to update the image. Now one way to do that is you could do a capital edit and deployment and front end, and then go here and change the image. Another way to do that is just using the kubectl set command. So you could do a set image. Let's run the help to find that out. So that's kubectl set image. You can say deployment name, and then the container name and the image, right? So let's try that. So that's kubectl set image for the deployment. The deployment name is front end, and container name. We need to find out the container name. So let's do a deploy front end. The container name is simple web app. Okay, so let's do that again. Kubectl set image deploy front end. Container name is simple web app equals just the image, and that's updated. Let's make sure it's updated. Let's run the describe command again, and we see that the image is set to v2. Okay, that's success. So let's run the curl test again and see what we're seeing. So we're still seeing blue, but we see green occasionally. So there's a lot of blue, and there's some. But we see the curl. Okay.
All right, so this is a
find out the
technique that I
name,
might just
and then
say.
that's kubectl.
Alright, so you want to change the existing deployment's image, right? Setting the image on the deployment to this thing. So you can just say kubectl edit deploy front end, and then do from there. And I can mention that somewhere over here. So let's see. I have another laptop that I'm gonna write down the notes. So So if you want to edit the deployment, okay, create kubectl, create -f deployment.yaml, get kubectl.get deployment, update kubectl apply -f deployment.yaml, and kubectl set image deployment. Okay, status, kubectl rollout status. Rollback deployment, rollout, undo deployment, okay. Roll back a deployment. Got it. So we say edit an image of an existing deployment. And then that would be simple. Like kubectl edit deployment. You could just say deploy. You just say front end, and then you edit it. Then edit the image from there and save. Okay, and run using, you already know, kubectl apply. Alright. Other way is to, or the other way around.
Set command, so you can do a set image. Let's run the help to find that out. So that's kubectl set image. You can say deployment name, and then the container name and the image, right? So let's try that. So that's kubectl set image for the deployment. Deployment name is front end, and container name, we find out the container name. So let's do a deploy front end. The container name is deploy container name. So let's do a deploy front end. The container name is simple web app. Okay, so let's do that again. Kubectl set image deploy front end. Container name is simple web app equals, that's the image.
Container, and then it should change like that. Front end image updated. So kubectl set image deploy front end simple web app is equal to code cloud and then we have web app dash web app color, and then we have v2. I can say I'm basically ready. Yeah, man. That should change the thing. Yeah, I mean, how long do I have to do this? I've been doing it for so long now.
And that's updated. Equals simple front end image equal. So let's do a container name. The name is front end, and container name, we need to find out the container name stand. So let's try that. The container name and the image, right? So let's try that. So that's kubectl set image we'll find that out. So that's kubectl set image. You can say deployment name, and then the container name and the image, right?
Kubectl set image, deployment
name, and then the container name will set image. You can say deployment name.
Deployment, and then we have deployment name.
And then the container name, image. You can say deployment name, and then the container name and the image, right? So let's try that. So that's kubectl set image. So let's try that. So that's kubectl set, right? So let's try that. So that's kubectl set image for the deployment. The deployment name is front end, and the container name. We find out the container name. So let's do deploy front end. The container name is simple web app. Okay, so let's do that again. Kubectl set image deploy front end. Container name is simple web app equals test image, and that's updated. Let's make sure it's updated. Let's run this command again, and we see that the image is set to v2. Okay, again, and we see that the image is set. Make sure it's updated, and that's updated. Let's make sure it's updated. Let's run this
Okay, describe deploy for now.
describe command again, and we see that the image is set to v2.
All right, that was perfect.
Okay, that's success. So let's run the curl test again and see what we're seeing.
Okay, now if you look, run the script curl test again. Notice the request now hit both the old and newer versions. However, none of them fail. Execute the script. Root test curl test.
So we're still seeing blue, but we see green occasionally. So there's a lot of blue, and there's some green. So green is a new version that we have deployed, and blue is the older version, and now we have a lot of green. Right. So if you look at this, there was a lot of blue at first, and then there's some green.
Oh, at first it was, yeah, and then it started getting more green.
And then there's green and blue at one point of time, and then we just have green. So that's how it's updated the application deployment. So that's the rolling update. Now, to how many pods can be down?
Alright, so if they ask for this particular thing, up to how many pods can be down for upgrade at a time? If you look at it over here. Just checking if the stream is okay. Looks good actually, but I just don't have any people or audience. Come on, give me some hearts, give me some laughs, give me some celebrations, give me some reacts. When can we turn into a famous stream, just like Speed?
For upgrade at a time. Now, to how many pods can be done?
How many pods can be done for upgrade at a time? Alright. Consider the current strategy settings and number of pods for.
The rolling update. Now, to how many pods can be down? The rolling update. Now, to how many pods can be down for upgrade at a time?
How many pods can be down for upgrade at a time? Consider the current strategy settings and number of pods for.
Time. Consider the current strategy settings. So if you look at this, the strategy type is rolling update, which we've already seen. There's rolling update strategy.
Okay, rolling update strategy 25% max unavailable.
The additional details here. So 25% max unavailable. So that means it's going to take down
out of 4, it's just going to take out on 1.
only 25% of the pods at a time before bringing the new ones up. So you have 4 replicas, and 25% of that is just 1. So let's select 1. Change the deployment strategy to recreate, and delete and recreate the deployment if necessary. So let's go ahead and try and change the deployment strategy. So let's do a kubectl edit deployment.
Okay. Kubectl
And we'll just go here and we'll just change the strategy type
Rolling update.
to
Strategy.
recreate.
To recreate.
And the recreate does not require the rolling update parameter, so we're just going to get rid of this.
Okay.
Parameter, so we're just going to, and the recreate does not require the rolling update parameter, so we're just going to get rid of this.
Okay. I think I've done
Okay,
that.
and let's verify.
Describe, deploy, front end.
And we see the strategy type is changed to recreate. Okay. The next one is to upgrade the application by setting the image.
Upgrade the application by setting the image on the deployment to this thing, which is v3. Do not delete and recreate the deployment. Only set the new image name for the existing deployment.
On the deployment to v3. So currently we have v2 and we've got
One second.
we change it to v3. And we see the strategy type is changed to recreate. Okay. The next one is to upgrade the application.
Upgrade the application setting the image on the deployment to code. Cloud web app color v3. Do not delete and recreate the deployment. Only set the new image for the existing.
By setting the image on the deployment to v3. So currently we have v2, and we're about to change it to v3. And let's use the same command, the kubectl set image deploy command, and we'll just change this to 3. Okay, so that's updated. And
Wow, that's so simple.
image deploy command.
kubectl set image deploy front end simple web app. So this is a Kubernetes set image deployment is the name of the deployment front end. Simple web app is the container name equal to the image name. All right.
And we'll just change this to 3. Okay, so that's updated. And next, let's run the curl test again. And when we run this time,
now what failures? Run the script curl test again. Notice the failures. Wait for the new application to be ready. Notice that the requests now do not hit both the versions. Execute the script.
Unlike the previous time, we see a lot of failures. So some of the requests are failing, and this is because it took down some of the pods as part of the upgrade because we're doing every create. So let's just give it some time.
You know, you'll have downtime
because we're doing every create. So let's just give it some time. If you look at the application here, it says bad gateway. Okay, and now you can see it started to respond. We have the red colors coming up, and when we refresh this, you see that we have application v3 and the red colors are coming up. Okay, so that's the end of this lab.
Wow. Lab deployment strategies. So that was rolling update. This is the lab rolling updates and rollbacks. So you want me to do it? Let me just do it then. I think I did the lab selectors. All right. Yes, you see, in progress. Completed. Deployment strategies. This is completed, man. Rolling updates and restarts. Rolling updates and rollbacks. Deployment strategies. What is this one?
In this video, I'm going to go over the solutions for the deployment strategy lab. The first question, it says a deployment has been created in the default namespace. We need to figure out what is the deployment strategy used for this deployment. So we'll do a kubectl get deployments. And here we have one.
Okay, you can see over here, kubectl get deployments. A deployment has been created in the default namespace. What is the deployment strategy used for the deployment? So simple.
One deployment called front end. So I'm going to do a kubectl describe front end, deployment front end. And if we go up to strategy type, we can see that it is a rolling update strategy. The deployment called front end app is exposed on the node port via service. Identify the name of the service.
The deployment named or called front end app is exposed on the node port. The deployment called front end app is exposed on the node port via service. I mean, you guys never gave any kind of donations on Buy Me a Coffee or Patreon, which is pretty sad. You know, I never got any of that on Buy Me a Coffee, especially. Let me show you. So I created this long time ago, but I never got a coffee. So if anyone wants to be the first one to support, they're more than happy to do that. Here is in the chat. Okay. And I also have other ones like Gumroad, Patreon. These are the cheat sheets you can buy to support me. And this is the Patreon page. See some exclusives. Oh yeah, and I remember I had to use, I think, the Patreon money one time for my Uber expenses. All the money that I made for like a year or something, and it just finished in like 3 days or 2 days on Uber expenses to go for work earlier here when I was in Austin.
If we do a kubectl get service, we can see that we have, if we do a kubectl, by the name of this, the deployment called a rolling update strategy. The deployment called front-end.
The deployment called front-end app is exposed on the node port via service. to pause at once, so I'm going to try to fast code all of this. If you guys had questions, let me know.
Strategy. Strategy type, we can see that it is a rolling update strategy. The deployment called to strategy type, we can see that it is a rolling update strategy.
Alright, okay, let's just get
The deployment called front-end app is exposed on the node port via service. Identify the name of the service.
The deployment named front-end app is exposed on node via service. Identify the name of the service.
If we do a kubectl get service, we can see that we have the front-end dash service. And if you want to just double check and verify that this is the right service, we can do a kubectl describe service. And we can just make sure that the labels or the selectors match up. So here we are using a selector called app equals front end.
Selector.
And if we go back to the deployment, we can see for the pod template, we have a label of app equals front end.
Label app equal to front end. I see it right. Selector app equal to front end.
So the answer to this question is going to be front end dash service. The next question is asking what is the selector used by the service? We already saw that. It's going to be app equals.
Used by the service. Describe service. Front end.
Next question is just telling us to take a look at the web application by clicking on the web app button right here. And that's going to be the application. The next question, a new deployment called frontend-v2 has been created in the default namespace using the image listed below. And this deployment will be used to test a newer in the default names.
A new deployment called front-end v2 has been created in the default namespace using the image v2. This deployment will be used to test a newer version of the same app. Configure the deployment in such a way the service platform routes less than 20% of traffic to the native and increase the replicas of the product deployment.
namespace using a new deployment. The next version, a new deployment called frontend-v2 has been created in the default namespace using the image listed below, and this deployment will be used to test a newer version of the same app. Configure the deployment in such a way that the service called frontend-service routes less than 20% of the traffic. Configure the deployment in such.
This deployment will be used to test a newer version of the same app. Configure the deployment in such a way that the service called frontend service routes less than 20% of traffic to the new deployment. Do not increase the replicas of the frontend deployment. Frontend v2 has been created in the default namespace using an image profile.
Deployment called frontend-v2 has been created in the default namespace using the image listed below, and this deployment will be used to test a newer.
New deployment of frontend v2 has been created in the default namespace using the image profile.
The next version, a new deployment called frontend-v2 has been created in the default namespace using the image listed below, and this deployment will be used to test a newer version.
This deployment will be used to test a newer version of the same app. Configure the deployment in such a way that the service called frontend service routes less than 20% of traffic to the new deployment. Do not increase the replicas of the frontend deployment.
The same app. Configure the deployment in such a way that the service called frontend-service routes less than 20% of the traffic to the new deployment. Do not increase the replicas of the front-end deployment. So if we do a kubectl get deployments, we can see that the front end, the original version 1, has 5 pods, and then front end v2 has 2 pods. And if we go back to the service, you can see that we're using the selector app equals front end. So let's take a look at the selector used on the front end v2. And we can see that it's also using app equals front end. And so that means traffic's going to get load balanced across both of these right now. And so there's 5 here and there's 2 here. And so what that means is to see how much or what percent of the traffic is going to front end v2, it's just going to be 2 out of 7, which roughly equals 28%. So to get that down below 20%, we're going to just remove the number of pods down to 10%. So to get that down below 20%, we're going to just remove, which roughly equals 28%.
Which roughly equals 28%, 2 out of 7. Okay.
So to get that down below 20%, we're going to just remove the number of pods down to 1, or the number of
Okay, we're gonna have
replicas sets down to 1.
bring the number of replicas set down to 1.
And so to reduce the replica sets down to 1, we're going to run the command kubectl scale deployment
Scale deployment.
dash replicas equals 1, and then we're going to call front end dash v2.
Ooh. to make front end service. Route less than 20%. Of traffic to the new deployment. So what we do is take kubectl scale deployment, scale it. We will scale down the replicas. So scale deployment, and then we say replicas, put a 1, and then v2.
So that's going to scale down. If I do a kubectl get deployments now, we should see only one pod for front end v2, and that's going to be a 1 out of 6 now. And that should be less than 20%. So let's check this. All right, so let's check out the app now. So if we open this up in a new tab, you can see right now it's still v1, but remember, less than 20% of the traffic will get hashed to v2. So we just have to keep refreshing a couple times until we get to v2. There we go, and I went right past it. And so we can see it's about a little bit less than 20%. All right, and so this is just saying that we've now established that the new version 2 of the application is working expected, and so now we want to safely redirect all users to version 2. And to do that, we need to scale down version 1 down to 0 replicas, and scale up version 2 to 5 replicas. So we can run the same command basically. This is just going to be front end, so we call version 1, and then we're going to set the replicas to 0, and then this time we're going to call v2 and set the replicas to 5. This is going to force all traffic to go to just v2. If I do a kubectl get deployment, we can see 0 to front end v1 and 5 to front end v2.
And you can just go and check it. It's gonna be
Now delete the deployment called front end completely. So I'll do a kubectl delete deployment front end. And when we do a get deployment, we should see only front end v2. And now if we reload the web app tab, we should see that only version 2 of the app exists. So I'm going to refresh version 2, version 2, version 2. It's always going to be version 2. And so that's going to wrap up the deployment strategy lab.
Alright, so we have the deployment strategies and we had the other one. So the deployment strategies.
Hello and welcome to this lecture. In this lecture, we will look at jobs.
We're going to look at these jobs and cron jobs, hopefully, and then we'll move on to section 7. So yeah, I'm going to come back after this. Hopefully this stream is still going on. I'll go back on this one. Just give me a moment. Back. All right. Oh man, we have limited time, so let's try to first do the rolling updates and rollback, and then do the other one. So I hope it's still being recorded. Should be on the stream. Oh, we have 4 people watching nothing. I wasn't. All right, let's do some action now. Thank you for staying. All right, restart. Picture yourself as an indomitable power filled with positive attitude and faith that you are achieving your goals. Well, that's a nice quote. Indomitable. All right. Cool again. So we have deployed a simple web application, inspect the pods and services. So you see over here, Kubernetes, kubectl, get pods. You can see over here 4 pods are there. And then we have kubectl, get services. You can just do this for short. And we have 2 services, alright? Wait for the application to fully deploy and view the application using the web app portal above the terminal. So web app portal, if you click on this, hello from front end, and then there's this thing, application version v1. It's blue color. Cool. So after that we have, what is the current color of the web application? Access the web, it's blue. So this is the color. After that, it says run the script named curl test.sh to send multiple requests to test the web application. Take a note of the output. Execute the script at... Okay, if you look at the directory right now, so we have this curl test. You could just say / curl test.sh. Okay, so right now we see that pods are there. Services are these. Web app service, Kubernetes. Okay, this is the node port 1, and then there's like 4 different pods. Each have one container, or yeah, and each container has an image. So if you run this, you could see over here all hitting the blue application version v1. After that, we have inspect the deployment of the default namespace and identify the number of pods deployed by it. Okay, if you look at the kubectl get deployments, and you could see over here we have one front end one which has 4 different pods. So we have over here up to date available 4. What container image is used to deploy the applications? Container image is used to deploy the applications. So you could say kubectl describe deployment and front end. So you can see over here what container image is used to deploy the applications. Container images. Containers, simple web app. And then the image is this one. Web app color v1. Code cloud web app color v1. Inspect the deployment and identify the current strategy. Strategy type rolling update. If you were to upgrade the application now, what would happen? Basically, if it's a rolling update, it means that all pods are taken down before upgrading any. Pods are upgraded few at a time. This is the first one, yeah. And that's recreate. Let's try that. Upgrade the application by setting the image on the deployment to this thing. Do not delete and recreate the deployment. Only set the new image name for the existing deployment. Only set the new image name. Okay. Kubectl edit deployment and what's it called, front end. Over here it's saying change the image spec replicas, 4 updated replicas. Alright, so we have spec containers, and then we have this insert mode, code cloud, web app color, v2. Alright, let's see. Alright, so let's see if that did the trick. It did do the trick. Awesome, bro. Alright, run the script curl.test.sh. Again, notice the requests and now hit both the old and newer versions if checked immediately. However, none of them fail. So if I run that script again, yeah, so you can see over here it's green, blue, you know, it's changing up. However, none of them fail. Execute the script. So it's kind of load balanced between both of them. Up to how many pods can be down for upgrade at a time? Consider the current strategy, settings, and the number of pods for. So we have 4 pods. 1, 2, 3, 4, 5. Why is terminating? Okay, we have 4 pods. It's gonna be down for upgrade at a time. Consider the current strategy, settings, and number of pods for. Alright, number of pods. Deployment. Cuddle. Get deployment. Alright, so we have front end, which has 4. Describe. Deployment. And we have front end. So oh yeah, so we have a rolling update strategy. Update. Consider the current strategy, settings, and number of pods for. Okay, so we have rolling update strategy here. We have for this is 25% max unavailable, and then we have 4 pods, right? So when you're like rolling update for every particular version, right? Now we changed that version to v2, the image of this deployment, and this deployment hits all the replicas here, right? So so it kind of has 1. It's gonna be down at a time. So 1 because it's like 25%, right? Okay, so change the deployment strategy to recreate. Delete and recreate the deployment if only update the strategy type for the existing deployment. You could do the same thing. Poop cuddle. Edit deployment, and then we have front end, and then here we're just going to change the strategy to type to recreate instead of rolling update. We don't need these strategy parameters like rolling update parameters. Here we have max surge and max unavailable, so we can just delete these 2. And then when I escape and save this, you'll see that the deployment is changed to a recreate strategy. Upgrade the application by setting the image on the deployment to this thing. Do not delete and recreate the deployment. Only set the new image name for the existing deployment. Alright, so there's this way to set the image. So I would say coop cuddle, set image deployment, front end, container name, simple web app, and then the image, what you want to set it to. And then you can see it should change. Run the script curl test.sh again. Notice the failures. Wait for the new application to be ready. notice that the requests now do not hit both the versions, because obviously you did let's have a curl test. So you can see over here right now it's all hitting green. Okay, now it's black, red. Okay, now see it's red. So we use the it kind of had to fail, and then it had the other thing. So that was basically it for this one. Now in this one, which has deployment strategies, just refresh this as well. I hear and I forget. I see and I remember. I do and I understand. They have really famous quotes, bro. Really nice quotes. Okay. A deployment has been created in the default namespace. What is the deployment strategy used for this deployment? I don't get it. Oh, yeah, the alias is working too. K get deployed, and then we have front end deployment strategy. K poop cuddle describe deployment. Front end. What is the deployment strategy used? So strategy type rolling update. The deployment called front-end app is exposed on the node port via service. I don't know the name of the service. It's pretty simple. Kubectl get service. So we have a front-end service, right? So all right, so I don't know how to do this. It is. I mean, if you just kubectl describe service, and then we say front end service. All right. So if I describe this, you can see over here we have a selector, and it's set to app is equal to front end, right? Now that should hit the deployment. So if you look at the deployment, describe deployment, and then we say front end, we have to look at the label of this. If the label matches, over here, app is equal to my app, tier is equal to front end. So over here you can see app is equal to front end, because the name is over here front end. So the label does match, and that's why we say it's front end service. What is the selector used by this service? What is the selector used by this service? What is the selector used by this service? Oh, that was simple. It was right here. App is equal to front end. Inspect this service called front end service. App : front end. Check out the web application using the web link above the terminal. Hello from front end. some kind of deployment, and then we have application version v1. That's the image, right? That's the image basically. We change the version. Image is basically the version of the application. A new deployment called version or front end deployment called front end v2 has been created in the default namespace using the image. Okay, this is the version, Code Cloud Web App Color v2. This deployment will be used to test a newer version of the same app. Okay. Configure the deployment in such a way that the service called front end service routes less than 20% of traffic to the new deployment. Do not increase the replicas of the front end deployment. All right. So if you look at the kubectl describe front end, describe deployment front end. So this is the old one, right? And it's basically a 25% rolling update strategy for max unavailable. And it's using the old version v1. But if we look at the kubectl get deployments, you'll see there's another deployment named version v2, which has two different replicas. Both are running and actually available. Now, if I look at kubectl describe deployment front end v2, you can see over here we have rolling update, and it also has the same versioning, but it has the image of the different. Now, come here, total are 7 replicas. So 2 divided by 7, because configure the deployment in such a way that the service called, because it's being load balanced. How is it being load balanced? Because my service, remember, it was targeting thing, which is, now this is the front end v2, but if you look at the labels here, app is equal to my app, and app selector is over here. App is equal to front end. Labels and selectors. App is equal to my app, and then over here as well too. This is the older version, remember the old one. And then over here too, selector is app is equal to front end. App is equal to my app. And then remember that service? That service is right here, front end service. And this label is app is equal to my app. Selector app is equal to front end. Labels, app is equal to my app. And selector app is equal to front end. So they're batching, and kind of it's like it's doing a it's kind of doing a load balancing technique where it's kind of going in both ways. But if I want to like have, so 2 out of so if I have to add all the replicas all together from the deployments, it's 7, 5, 6, 7, and 7. So basically 2 is from the front end, so 2 divided by 7. I'll pull up a calculator. 2 divided by 7 equal to, so it's around 20. So you see 0.28 multiplied by 100. It's like 28% something right now. The traffic is going to version v2 deployment. But we have to route less than 20% of the traffic to the new deployment. To do that, I think we can just take down the replica count to a little less, scale it down. So kubectl scale deployment front end v2, and then we have replicas hyphen replicas, and then we just say 1. All right. So that's it. I'm getting good with DevOps. Check out the new version of the web application using the web app link above your terminal. You may need to refresh it multiple times to see the new version, because since right now 5 of them I refresh. Same, it's in the first deployment. Same, right? And you know, these are different containers, or you can think about a front end, the different pods that are there. But when I'm gonna get a new deployment, so I'm not getting anything right now. There you go. Now when I refreshed all the way, because now it's accessing the second second deployment, and it has another pod over itself, and the version is V2. This is the newer version of the application. So we have now worked with the new version V2 of the application. Is working as expected. You can now safely redirect all users to the V2 version. Okay, if that works, then we can just like scale down the first one, scale down the V1 version of the apps version to 0. Those are pods, replicas, and scale up the new V2 version to 5 replicas. That's simple. So we have kubectl, scale, kubectl, scale, deployment, and then we have deployment name, front end, hyphen replicas, scale down this one to 0, and front end V2, scale these replicas to 5. And I think it should now all times go to the new one. That's crazy. And these are all the different pods of them, right? Or replicas. It's a complete replica set. So now you can delete the deployment called front end completely because it's old. It's like obsolete. You can see like it's an older version. So you could say kubectl just delete deployment front end because it's no longer being used. And you can now reload the web app tab to validate that all user traffic is now uses the V2 version of the app, and we did that. And basically that ends our lab session, and we kind of submit it. And we're gonna like do cron job. So these cron jobs are just gonna, it's very simple, short, and then hopefully we can move on to the next part. So far, if you guys like this, let me know. I'm gonna take a pause here, but I'm gonna come back. Oh, okay, I can see through this as well.
and welcome to Rawalpindi Cricket Stadium. KFC presents Vigotel Mobile Tri-Nation Series 2025. The first game, Pakistan take on Zimbabwe. Salman Ali Agha won the toss. He had no hesitation in having a bowl first. Bit of experience in that middle order. Brendan Taylor, Sikandar Raza, Ryan Burl will have to make sure that they get a decent enough total to defend. With Pakistan, Simon Farhan up the order, Babar number 3 now. It'll be interesting where Fakar bats. Usman Khan also there. 2 fast bowlers, a Brar in there to provide mystery spin. Brian Bennett to take strike in the first delivery from Shaheen Shah Afridi. Edge and flies away down to third. Footwork doesn't work, so boundary of the very first ball. Oh, gets the gap. Didn't middle it completely, bottom of the bat, but it is enough to get to the fence. Second boundary of the innings. In the air, in the gap. This is much better timing. And Bennett, it's a boundary through square cover. He pulls it away. The outfield is lightning. It's not timed perfectly, but we'll get to the fence. The short ball is pulled in the air. But there is space. One bounced into the fence. Down the ground. Again, bottom of the bat, but enough. There'll be another boundary. Slow ball picked and thumped away leg side. Bennett dealing in boundaries.
Saim Ayub is treated nonchalantly. That really travelled long and far. Now that is some shot. That really is middled. Picks up the length early. Fahim Ashraf with a big dive. It's not going to be another boundary. And Zimbabwean openers are on a roll here. Yeah, powerful player off the back foot once again. It misses the field. The 2 fielders, Babar Azam and his mate, were locating the ball and beautifully. Babar Azam, back foot once again. It misses the. Yeah, powerful player off the back foot once again. It misses the field. The 2 fielders, Babar Azam and his mate, were locating the ball and beautifully timed and placed. And that's taken brilliantly. Shaheen Afridi there, inches from the rope.
It's a full toss. He can plant it anywhere he likes, and he picks out the fielder. And Nawaz, very happy with that. He's gone for a well-played 30 from just 22 balls. Zimbabwe 72 for 1.
Brendan Taylor is the new man in. Reverse sweep shot played superbly along the ground.
This time he gets bat. Somewhat a bottom edge and a very good over. He wants to. I think they have him. I think he's short. A good throw from Babar Azam in the deep. He looked through it. Somewhat a bottom edge and a very good over. He wants to. I think they have him. I think he's short. A good throw from Babar Azam in the deep. He looked short. Yeah, he looked short. Makes the walk back to the pavilion. Run out for 14. Zimbabwe are now 91 for 2. Ryan Ball, left-hander. 31-year-old. He can strike a ball. Okay. Oh, he's chipped it back. That's the 3rd wicket. Such a soft dismissal.
That ball gripped.
didn't spot that leg spinner from Saim Ayub offered. An easy catch, return catch. Didn't make any mistake. Pakistan back in this game. They have gotten rid of Danger Man for 49. It's 94 for 3.
Flat bats it. Skids away for 4. That's high. Babar Azam. He's underneath it. Takes it. Ryan Burl goes.
Force the batter to top edge that one. And things were spruced up by Babar Azam. Very well judged catched. And it's wicket number 4 in shape of Ryan Burl. He goes for 8 and it's 106 for 4.
It's Tony Munyonga.
Oh, hurry back. Hurry back. Oh.
Hey, Alicia Little here, and I'm excited to announce that the 3rd annual AI and Marketing Summit is here. This is the AI Marketing Summit.
Oh dear. I don't know that he got back there, Munyonga. Set off and then had to do a big circle to get back. Nope, short of his ground. A long way. Big back there. Hurry back. Oh. Oh, hurry back. Hurry back. Oh dear. I don't know that he got back there, Munyonga. Set off and then had to do a big circle to get back. Nope, short of his ground. A long way short of his ground. Gone for 3. Zimbabwe are 112 for 5 now. Tashinga Msekiwa. Shot. That's really well played in the slot, and it decides, well, I'll just help that on its way. Sikandar Raza, and he has to come to the party here to repair the damage that has happened in the last little while. Ball him! Didn't pick it at all. And straight through, crashing into the stumps. Another one down.
It's another example of inexperience, another example of you've got to be cleverer than this to bat well in the middle phase of the innings. The middle order has caved in. Nowhere near the ball, missed it completely, and he castled him. Could only get 2. Tashinga and Zimbabwe reeling now, 119 for 6.
Brad Evans walks out to the middle. That's gone up in the air. Simple catch off the leading edge as he tried to work it onside. Evans, it's been a procession.
You've just come in, and your role has had to be to partner Raza to get some runs and to be engaged in a partnership. A very, very soft dismissal. Brad Evans, only 2. He got a 5, 1, 2, 5 for 7.
Bowl him! A wild swing.
He almost played a perfect shot when he was dismissed. That shadow practice of playing with a straight blade is what was needed on that occasion. Going across the line, and well, it did not make matters happy for Zimbabwe. They slumped further. Lost another. 8 down now for 128.
It didn't quite come out the middle of the bat, but it struck well enough. And away it goes for 4. Shot. Oh, wonderful. Fine leg up in the circle, and he just gets out the way with his legs across to the offside. Oh, wow. What's up? Enough. And away it goes for 4. Shot.
For one is happy for Zimbabwe. They slumped further. Lost another. 8 down now for 128.
It didn't quite come out the middle of the bat, but it struck well enough. And away it goes for 4. Shot. Oh, come on.
Further. Lost another. 8 down now for 1-8.
It didn't quite come out the middle of the bat, but it struck well enough. And away it goes for 4. Shot. Oh, wonderful. Fine leg up in the circle, and he just gets out the way with his legs across to the offside. Oh, wow. What a shot that is. Use of the feet, and then the crack of the blade. And it's gone all the way for 6. Sikandar Raza. Final delivery. Dot delivery. Well bowled, took all the pace off again. 12 off the last one. And Zimbabwe end 147 for 8 off their 20 overs. Having put 72 on for the first wicket, they'll feel that they should have got a lot more.
Last 2 overs, 19 runs for Zimbabwe, courtesy Sikandar. And in those 2 overs, we saw everything regarding T20I batting from Raza. The placement, the deft touches, the straight 6. Ends up with a 34 from 24. The opening was brilliant from Bennett and Marumani. But then the middle order had nothing to offer. And in the end, Zimbabwe would be disappointed with a score of 147 for the loss of 8. It could have been a lot better.
2 wickets for Nawaz. The spinners really is who to look at because they changed the course of the game. Pakistan need 148 to win here and start off with a victory in the tri-series.
Off with back off for length. Grava does have a bit of pace about him. He gets extra bounce, quite tall, hits the pitch hard.
In the air, is off the mark with the boundary. Was well in control. Sabzada Farhan never tried to overhit the ball.
Hits it through the offside. It was pitched up and he's crunched it through. Rob around the wicket, he slashes hard. There's no one deep on the offside, so he'll collect a boundary. That's the shot he was looking for. This time he nails it, and that goes all the
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44.
way. Robert pitched up and he's crunched it through. Rob around the wicket, he slashes hard. There's no one deep on the offside, so he'll collect a boundary. That's the shot he was looking for. This time he nails it, and that goes all the way into the crowd. A maximum to end the 4th. Bowling, nips back. Sabzada Farhan giving himself room, but that was too good from Evans.
He was looking for a bit of room to be able to play that stroke through. Covers kept coming back to him, and there was a lot of gap between bat and pad. First blood drawn by Zimbabwe, and it's Sabzada Farhan.
Fan favourite, Babar Azam. And again, huge appeal and given. That is a big moment. Baba thinks down the leg side. It has seamed back in. Will he go upstairs? Discussion. Yes, they go upstairs. Baba's third duck in the last 6 innings in T20Is. Huge moment in the game. Salman Ali Agha, captain, walks in.
No, I think it's given. So it was boot before bat, and he's done, according to the umpire.
Now remember, if he goes up, he's been given out, so even umpire's call will stay out. I think that's a very good decision from the umpire.
Original decision out. Impact umpire's call, wicket hitting. Asif stay with original out decision standby.
Fingers is raised once again, and Pakistan in a bit of bother here. 3 down now for 30. View here is Fakhr Zaman, left-hander, being asked to bat in the middle. Making it to the fence quite easily. First boundary in 3 overs. Saim Ayub belting it past mid-wicket. Big shot, 6, is it? There's a fielder there and he's gone, Saim Ayub. This is a magical breakthrough coming just at the right time. Partnership has been broken. 24-run partnership it was.
Bottom of the bat. Tried to hit it to Dubai, but couldn't get it out of the border of Islamabad, capital territory. 22 of 26 for the opener. Pakistan are 54 for 4.
Usman Khan and Fakhr Zaman now together.
Another long hop, but this time around didn't get away. A real thumb from Usman Khan and a boundary scored.
Shouts of catch it, but it's hit well, and it'll go over mid-wicket and go for 4. Up, catch it. Shouts of catch it, but it's hit well, and it'll go over mid-wicket and go for 4. Up and away. Oh, that is some strike. In the slot, and he loves those. Feasts on them. Fakhr Zaman, 6er.
If you want to flat bat the ball, this is the line and length you require. Bit of room outside the off stump, back of the length, and that was more than enough for Fakhr Zaman to pounce on the opportunity. That's his natural ability. It wasn't a bad delivery, but pure class. Ability of the left-hander.
Oh, it's just the length he loves. It's the wrong one, but the angle just brings it nicely into that arc. And he's able to get at it. Whoa, that is swatted. That is absolutely belted away for 4.
Short ball slashed. Kind of a semi-uppercut. Runs the ball fine away from the fielder into the fence. Here comes the flick taken by the keeper. He is walking. He is done for the night, Fakhr Zaman, and what a costly blow. Hurt on the wrist by that straight smash, and in the end, bit of cuteness from Fakhr Zaman, signalling his downfall.
Now trying the ramp shot, it was the slow one. Brendan Taylor does well, coming forward. It's a good wicket. Zimbabwe needed this. Good little knock from Fakhr. 44 of 32. Pakistan 115 for 5.
Made for any situation these days. Mohammad Nawaz is in. Big shot. Cracks it. 6. Nawaz for you.
Was excellent with the ball and now with the bat. That is brilliant. Stayed with the shot and been able to clear the fence and more.
It's a big shot that's gone up in the air. Will it clear the fence? Fielder drops it. Nawaz had the perfect idea because Pakistan needed a big shot and it'd be disappointed. Bennett there grasping that one. It's a difficult one.
Yeah, big moment in the game. He did all the hard work, got underneath it, but just couldn't settle himself.
Slow ball, and it's misfielded, and that's gone to the fence. The crowds are back, alive and kicking.
我が艦が初の戦果を上げました。敵巡洋艦を撃沈。
Alive and kicking. The crowds are back, alive and kicking. And that's gone fine, beautifully played by Nawaz. He can do nothing wrong these days. Such a good, delicate shot, and he enjoyed it perfectly. Yeah, winning shot. Nawaz does it again for Pakistan in a crunch situation. He batted so calmly, so beautifully, in control of things. Whilst credit to Zimbabwe for making this a happening game after being limited to less than 150 on what appeared to be a very good start in a good pitch to bat on, but just didn't have enough strength to get back into the contest after Fakhr and Usman Khan belted a great partnership. In the end, Usman Khan remaining not out, played with a lot of composure, and Nawaz there, once again, the key to success for Pakistan in the middle phase of the innings with the bat. 151 for the loss of 5. Fakhr Zaman was the highlight of the innings with a top score of 44 of just 32 balls. Usman Khan 37 of 28 batted, resolutely batted well. Didn't throw his wicket away. Nawaz in the end 21 of 12, making it rather easy for Pakistan to get over the line.
Wickets for Angrava and Maposa.
Now,
in Kubernetes. Hello and welcome to this lecture. In this lecture, we will look at jobs in Kubernetes. There are different types of workloads that a container can serve. A few that we have seen through this course are web, application, and database. We have deployed simple web servers that serve users. These workloads are meant to continue to run for a long period of time until manually taken down. There are other kinds of workloads such as batch processing, analytics, or reporting that are meant to carry out a specific task and then finish. For example, performing a computation, processing an image, performing some kind of analytics on a large dataset, generating a report and sending an email. Hello and welcome to this. Hello and welcome to this lecture. In this lecture, we will look at jobs in Kubernetes. There are different types of workloads that a container can serve. A few that we have seen through this course are web, application, and database. We have deployed workloads that a container. We'll look at jobs in Kubernetes. There are different types of workloads that a container can serve. A few that we have seen through this course are web, application, and database. We have deployed simple web servers that serve users. These workloads we have deployed are web, application, and database. We have deployed simple web servers that serve users. These workloads are meant to continue to run for a long period of time until manually taken down. There are other kinds of workloads such as batch processing, analytics, or reporting that are meant to carry out a specific task and then finish. For example, performing a computation, processing an image, performing a computation, processing an image, performing some kind of analytics on a large dataset, generating a report and sending an email, etc. These are workloads that are meant to live for a short period of time, perform a set of tasks, and then finish. Let us first see how such a workload works in. There are other kinds of workloads such as batch processing, analytics, or reporting that are meant to carry out a specific task and then finish. For example, performing a computation, processing an image, performing some kind of analytics on a large dataset, generating a report and sending an email, etc. These are workloads that are meant to live for a short period of time, perform a set of tasks, and then finish. Let us first see how such a workload works in Docker, and then we will relate the same concept to Kubernetes. So I'm going to run a Docker container to perform a simple math operation, to add two numbers. The Docker container comes up, performs the requested operation, prints the output, and exits. When you run the docker ps command, you see the container in an exited state. The return code of the operation performed is shown in the bracket as well. In this case, since the task was completed successfully, the return code is 0. Let us replicate the same with Kubernetes. We will create a pod definition file to perform the same operation. When the pod is created, it runs a container, performs the computation task, and exits, and the pod goes into a completed state. But it then recreates the container in an attempt to leave it running. Again, the container performs the required computation task and exits, and Kubernetes continues to bring it up again. And this continues to happen until a threshold is reached. So why does that happen? Kubernetes wants your applications to live forever. The default behavior of pods is to attempt to restart the container in an effort to keep it running. This behavior is defined by the property restart policy set on the pod, which is by default set to always. And that is why the pod always recreates the container when it exits. You can override this behavior by setting this property to never or on failure. That way, Kubernetes does not restart the container once the job is finished. Now that works just fine. We have new use cases for batch processing. We have large data sets that require multiple pods to process the data in parallel. We want to make sure that all pods perform the task assigned to them successfully and then exit. So we need a manager that can create as many pods as we want to get a work done and ensure that work gets done successfully. But we have learned about replica sets that help us create multiple pods. While a replica set is used to make sure a specified number of pods are running at all times, a job is used to run a set of pods to perform a given task to completion. Let us now see how we can create a job. We create a job using a definition file. So we start with a pod definition file. To create a job using it, we start with a blank template that has API version, kind, metadata,